Hello, ngHouston. So tonight I am actually obviously not at home, but I could not miss this episode because I'm pretty excited. Tonight this actually started by request. I've had a lot of requests for this. We're an Angular group, but I have a lot of people who ask me about .NET. And I personally don't know a lot about .NET, but I know it's very strong and it's been around a long time. And so I've actually been approached a lot by people asking me about using .NET with Angular. And so I went on a quest to find a .NET expert who also is an Angular expert to come in and teach us some cool stuff. And I found one, and he's here tonight, and I'm super excited. So we're going to get to him in a minute, but first I want to introduce Lance, who is our one and only, well, I'm a panelist too, so I guess we have two panelists. So Lance, and you've been here before, everybody knows you, but come on and say hello for us.
Yep, my name is Lance Finney. I'm in St. Louis. I work for Oasis Digital, writing Angular programs and do training for Angular Bootcamp. And I have a bunch of history with Java. I've never done anything with .NET. So I'm going to be bringing a different perspective to this. I hope I learned something, and hope that the similarities between Java and C# don't steer me too wrong.
I think it's going to be awesome. I'm super excited. So Jeremy, tell us
Hello.
about yourself. You've never been on the show before, and I know you. I already like you a lot because we were just chatting before we went live, and you're super cool. I think this is going to be a super fun episode. So do you want to tell us about yourself, or you probably have a slide for that, don't you?
I do have a slide. I knew that we had limited time, so I cut back the bio part to just 20 minutes of background, but I promise I have a lot of solid content. But seriously, I'll give some high-level background. I've been working in .NET for ages. Did a lot of work with Angular, started with the early beta on the JavaScript side of things and went through to the solid Angular. And when I say solid, 2.0 and 3 and 4 and 5 and 6 and the crazy version changes. So I'll talk some perspective about that. I am originally from Atlanta. I've been in Atlanta for, 20 years, I think. Prior to just last month, I packed the family up. We drove 7 days from Atlanta to Seattle and went house hunting the next day, put an offer in on a house, and now I'm moved into my new place in Monroe, Washington.
That's so great. You know, I grew up in Washington.
I did not know that.
Yeah, they say Washingtonians don't die, they rust.
Nice.
But there's so much rain. It's like the trees and the bushes just so green and lush.
It is. And when there's not rain, it's amazing.
Yeah, it really is.
Completely amazing.
Well, thank you so much for visiting us and coming. We had someone who was asking about .NET and Angular, and I was like, I don't know, but I can find someone who knows. And it took me a little while, but I found you, and you're here, and I'm super grateful. And I think we all are. And I don't know. So this is an unusual thing for ngHouston because we're a very small group. But I think I'm blaming you for this because we have a lot of people watching online tonight, and we don't normally have that many people. So if you're new to ngHouston, welcome. Thank you very much for coming. And now I'm nervous because I'm not used to so many people watching us. So Jeremy, you're kind of famous.
I think they're all good people. And it's good to note, too, that even though this is ngHouston, I believe you stream all your events, right? So anyone watching, even if they're not in Texas, should feel happy to look at your schedule, see who else is coming on, and jump on future streams as well, right?
We live stream almost every week. Some random Angular. It's always Angular, obviously, because we love Angular. But yeah, we live stream almost every week, and we have probably 50 or 60 past episodes. We have some good episodes. Nobody like you, obviously.
You're building this up so much, the pressure. I don't know. I can't take it. Let me jump in and let's see if we can get past the first slide, and then we'll talk about how good or bad this is going to be. Does that sound like a plan?
That sounds great.
All right.
Let's here to ask questions. And so for anyone who's watching online who's not used to this, we love questions. So if you're on YouTube, there's a chat there, and you are welcome and encouraged to ask us questions in the chat, and we'll try to get those answered.
Sounds great. I should be sharing now. You should see the first page. Yes, no, maybe?
Yes.
I have the most creative Twitter name on the planet. It's at first name, last name. I decided to to go that route. I'm going to start out with just a little bit more about myself. I did a light intro. I've been professionally developing for over 24 years. It's quite a bit of time. Half of that was on the product side of things, working for companies with internal software projects. Half of that was working as a consultant for several different companies. And then I'm starting on the third half of my career, as I jokingly say, as a cloud developer advocate. I'll talk a little bit about what that means in a minute. I do want to point out my contact information. I blog about all things cloud development related. My Twitter has open direct messages. That means that you can reach out to me if you have questions or need feedback and want to start a dialogue. That's open for anyone. And that is my actual email address at Microsoft if you want to provide me with feedback. I am part of a massive team of cloud developer advocates. We are around the world. We are in different regions. And we specialize in different technology areas, everything from containers to Linux to front-end development to what the team I'm on is the .NET team, but we have a lot of crossover. That first link you see will get you to the list of advocates. You can find out who we are, where we're at, how to get in touch with us, what we focus on. And for people who ask me what we do, I talk about 3 C's. That's the easiest way to remember it. And those 3 C's start with content. We're very focused on online content, whether it's open source projects, documentation, articles, blog posts, or videos. We work very hard together to provide the best possible content so that developers have a great experience. The second piece is community. It's everything from live streams like this, local meetups, conferences, online communities, wherever they're at, LinkedIn, Twitter, probably some places like Instagram that I'm not new and savvy enough to have mastered the art of. But we like to go where developers are at. That's the community piece. But the important thing is we do not report up through marketing and sales. We actually report to engineering, and we have a very strong relationship with engineers at Microsoft. That means challenges you face are challenges we can take directly to those engineering teams and help make that a better experience. Today, I'm talking about Angular and .NET Core, and I have 4 general areas I'll cover. I do want to give some background for .NET. I realize not everyone here has a .NET background or is familiar with it. Obviously, you would want to know why we would even use .NET with Angular. I'll talk about how they work together, and I also want to talk about where they can be hosted because there's some pretty cool hosting options for that. Now, having said that, I'm going to be focused mainly on .NET Core. .NET Core is a flavor of .NET, and I'll talk about how they compare in the bigger picture in a second. .NET Core came out a few years ago with version 1, and you see ** web on this slide because it really was built initially for modern web app experiences. It's a version of the .NET framework. It uses languages that compile to the .NET framework like C#, F#, but it was not compatible with the .NET framework that a lot of developers were used to. It was for more net new experiences. A little while later, .NET Core 2 came out, and .NET Core 2 addressed a lot of compatibility. The people who wanted to bring old applications forward into a newer version were able to do that because of the new APIs, and we'll drill into that. What's important to know, 2 things about .NET Core is 1, it is cross-platform, and I'll show you the platforms it runs on, and 2, it is open source. So there are open source projects you can go to on GitHub to look at both the code itself behind .NET Core as well as the documentation. And a lot of people don't realize this, but docs.com will take you to docs.microsoft.com. It's our document repository. It's a massive open source project. All of our documentation is open source. It's based on Markdown. And if you find problems with that documentation or have suggestions or feedback, you can do that directly through that mechanism. .NET itself started back in 2002. I think I wrote my first .NET application either later that year or early 2003. There was a little bit of a gap between versions, and this is kind of historical across the software industry, right? We were aligned on these big releases that would happen every quarter, every 6 months. Now everyone's continuously releasing. We've got DevOps pipelines in play. what used to be considered a unicorn is now reality. .NET Core has a shorter lifespan. It came out in 2016. 2.0 came out back in August of last year, and Core 2.1 just came out in May. Interestingly enough, October 1st is the end of life for Core 2.0. So Core 2.1 is the main player today. Now, .NET Core is defined really as an implementation of the .NET standard. And for people outside looking in, they see .NET, .NET Core, .NET Standard. There can be a lot of questions about what's going on. So I just like to call out that .NET Standard's the interface, and .NET Core 2.1 is one of many implementations. And historically, .NET developers, when they had to work on projects that might be part desktop project, part Silverlight browser project, part mobile phone project, one way we'd share source code files was as links. So in the IDE, we'd say, add this file as a link, and we'd have one copy we'd change, but it was actually getting compiled into separate classes. Something called the portable class library came out, and this worked on a lowest common denominator. What happened was I would pick the frameworks I wanted to target. I want desktop, I want browser, I want phone, I want Xbox 360, and it would find the APIs that existed on all of those platforms. So the more platforms you picked, the lower surface area you had. And this is because, for example, a phone API may not exist on an Xbox. .NET Standard turns this on edge and sets the bar. And it says that to be an implementation of .NET Standard, you have to implement all of the APIs that are defined. What happened here is you can see we've got infrastructure, compilers, different languages that go into that standard. That's the interface portion. And then we have an implementation, and those implementations are across the desktop. .NET Core is the cross-platform version, Windows Universal Projects. We even have a technology called Xamarin that uses .NET and targets iOS, Android, and I believe even Windows tablets as well for that. When .NET Standard 1 came out, there was a low surface area. So it was a small set of APIs, and all of these technologies you see implemented them. .NET Core, .NET Framework, Xamarin, even Windows 8 and Windows Phone 8, which is some older tech. .NET 1.6 expanded the APIs. What happened was there were some cool new APIs in .NET Core that the framework didn't have. So those were added into the framework. .NET Core didn't have to have a new release because it already had those APIs. Windows 8 and Windows Phone 8 were taken away, and then UWP was revved to a new version just to include some more APIs in the standard. 2.0 was the big release that added 20,000 new APIs. It completely deprecated support Windows 8, Windows Phone 8. There were new versions across the board of the technologies, but the 2.0 APIs are implemented in all of these technologies across the stack. So we can run it on an iPhone, on a Mac, on an Android. We can run it on a Windows desktop, and on a Linux machine or other flavors of that. What's interesting is we have a package manager called NuGet, and think of that as NPM for .NET applications. And if you look at these hundreds of NuGet packages and analyze the APIs they're using, pretty much 70+% of those are API compatible with .NET Standard 2. That means the owners of those packages, without changing code, could retarget to .NET Standard and package it up in a way that it'll hit all of those platforms and be available across that surface area. The APIs range from data, XML, serialization, networking, I/O, threading, and core. And all of these are implemented on all the targets. So there's Linux implementations, there's Mac implementations, threading, core, etc. of all these. These are the platforms, and this list of platforms is actually growing. I should have spot checked this before because we probably have support for some more Linux flavors, but we can run .NET Core apps as far back as Windows 7. We can run it on Mac OS, and we can run it on these different flavors of Linux. So it's a true cross-platform, and the way it works is the dynamically linked libraries, or the packages, if you will, that come out of it, if you think of a Webpack analogy, those can be dropped onto any of these platforms and run through the .NET engine. It's not like they have to be recompiled for each target. There's a choice of tools to work with it. The traditional .NET developers grown up on Visual Studio, which is a massive interactive development environment with tons of features and functionality. A lot of developers today who aren't necessarily Microsoft-focused developers or even .NET developers are familiar with Visual Studio Code. It's a very lightweight cross-platform editor that has these extensions that give it very powerful capabilities, and you can do most of what you need or want to do from this. And this is cross-platform open source tool. And then we have an implementation of Visual Studio for Mac. So all of these are targets.
Yeah, it's funny with the Visual Studio Code. I've been using that for about a year to write my Angular code, and I'm happy with it. But as I said it during the introductions, I'm a Java guy, so I spent about 15 years hearing that, Microsoft languages and tools were, coming from the evil empire, and now I'm writing in TypeScript and using Visual Studio Code. So it's a very different world than it was, 10, 15 years ago.
I appreciate that insight too, because if it came from me, I'm a Microsoft person talking about how Microsoft has changed, but it's exciting for us to see it from the outside because we really have evolved to embrace open source as a first-class citizen. In fact, little known story, I'll just share a tiny secret. When I interviewed at Microsoft, my first position was not for this cloud developer advocate role. I had a recruiter reach out to me about a different position, and they were not happy with my open source contributions. They wanted me to be a more heavy hitter in open source to align to that position. So that just gives you some insight into how important that is. What you're seeing here is a difference between ASP.NET Core 2 and ASP.NET Core. ASP.NET sits on top of .NET Core, so it's ASP.NET Core, and it provides all of the web experience. So if you're building a web-based application, you're going to use ASP.NET Core. And there's performance improvements with every release. This is the traditional ASP.NET or the original ASP.NET that was out before the .NET Core flavors came out. So you can see a lot of performance improvements, and there's benchmarks you can go to, third-party benchmarks that compare it to other sites. I will set this link up both on the Meetup site as well as tweet it out so that you get these links to see the full documentation, read more about .NET Standard, and if you're excited and interested, get started with .NET Core. Of course, what I'm here to talk about is how .NET Core works with Angular. And there's a few different scenarios that are in play with this happening. The first is a typical setup that you may see with Angular just as a static website. So there's nothing in .NET Core that really caters to the Angular experience. It's just used as the back-end engine, if you will, and can do things like authentication. It can stand up REST endpoints, and I'm going to show a little bit of why it's a very straightforward, easy experience standing up API and backends using .NET Core and then being able to run it if you want on a Linux machine or on a Windows machine. There's also Angular hosted in .NET Core. It's like a static website. In other words, there's a compile process where Angular package is emitted, but then it's hosted within the same website as the backend. And there's some advantages and disadvantages to that we'll talk about. And when you follow that approach, there's also a third way you can look at it and take advantage of server-side rendering. So I'm going to talk a little bit about that. But first, I want to just look at the straight Angular as a static website. Anyone here familiar with Angular should be familiar with installing the command line interface, creating a new application, and serving it. So that'll open the application and run it. There's about 10 minutes as you download the entire internet in there with the npm install, but other than that, you go straight to it. The .NET Core, and this is showing an example just to build a REST endpoint, is a similar experience. We have a command line interface. We do .NET New, Web API, .NET Run. That also will load down dependent packages, compile, and run that experience. I'm going to jump over now and show you some of what this looks like. This is me on a Linux machine, and I'm going to just pop over to the Windows side. So I'm in Windows. I'm going to make a directory called ngHouston API. I'm going to change into that directory. I'm going to do .NET New. What .NET New will do is it'll give me a list of templates that are available for different types of experiences that I want to build with .NET. I'm going to focus on this. Let's see if I can mark it here. This web API experience, which is what I use to stand up REST endpoints. So what we're going to do, I'll go ahead and clear and do a .NET New web API. This is going to scaffold the application for me. It's pulling down the packages that are dependencies and restoring those just like npm install would pull into node modules. And then I can do .NET Run to stand this up. And this has a built-in lightweight web server called Kestrel. It's a cross-platform web server that will stand this up sort of like when you do an ngserv command. So we can see that we've got a certificate out of the box. So we have an HTTPS connection. I'm going to go ahead and open that up. And here I'm going into Inception there for a second. So we're going to do HTTPS localhost 5001. And this isn't going to give me anything back because it's standing up an API that has a values path. Let me just zoom in there so you can see what I'm typing. So if I go to values, it's bringing me back value 1, value 2. I haven't installed the development certificate. That's why I'm getting that error that it's not secure. And here I'm getting a single value. You can see that experience. Let me close out of that. We're back in Inception. We'll bounce out. And I'm going to stop this because I want to show you just that if I pop over to the Linux side, I've got my Windows drive mounted here. So I'm going to go into the ngHouston. And I'm not going to do anything else but .NET Run. So I'm just doing that same command, only this time I'm on a Ubuntu subsystem that's running full Linux, just layered on top of the hardware of my machine here. Now this may take a little bit longer because it has to restore some other packages in the background. So I will look to see if we have any questions. And I'm also going to do this trick. I try to share it often because it's worked well for me, and that's rotating the mouse clockwise. Sometimes that seems to speed things up for us if we're having trouble getting something to run. I'm going to give this a few seconds.
We don't have questions yet. We just have Michael giving Ben a hard time. They remind me of my brothers.
Back and forth in the chat window.
Yeah, it's interesting to see you using Linux and Windows like that. I have downloaded that and installed it on my computer. I have Windows 10, just enough to say, yeah, I have Ubuntu on here, and then I haven't actually had a good reason to use it yet. But technology is amazing these days. I know another Microsoft employee, Scott Hanselman, recently had a podcast episode about WSL, and it was interesting to listen to some of the technology behind that, but I haven't made use of it myself.
Yeah, it's I come from a background. I actually did Java back in the day, and I would also build my own Linux machines back when you had this custom build, and you'd walk through source code tweaking flags, even to the point that you had to enter a matrix of numbers for timings for your monitor to get it correct. It was scary days because you could fry your monitor if you got that customized Linux build wrong. What I'm showing here is some values that have popped up. This is the same server. It's using Kestrel, only this time it's on the Linux side of things. So I'm going to stop that. And now let's look at something a little more practical. So what I've done is I've opened up what was generated in Visual Studio Code. And in Visual Studio Code, there's extensions for just about anything you can imagine, and community can contribute. So if there's areas that you want extensions, you can build those and bring them out. And right here, I've defined an API controller. So right now I'm saying that this class is going to be responsive like a REST API, and I'm giving it a route that's at the controller level. A controller might have multiple endpoints on it. So this route, because I use this controller in braces, is going to be called by FERC. It's by convention. So whatever the name controller, it'll take that name for the path. So it's going to be API by FERC. Now what I'm doing here is I'm specifying a verb, telling it that this is going to be a get endpoint, and it's going to have a path in the route, this R value. This is going to be a float value that I pass in. And what will happen is it's automatically going to pull that off the route, pass it in for me. If I put a string in its place, it's going to throw an exception, but I can track for that exception. I might even bring it in as a string and do the test myself so I can have a better error message. You have total control over this. We're going to iterate a number of times using a recursive equation, and we're going to skip some of the results and just throw them out so that it settles to a value, and I'll show you what that looks like. So I'm just writing out to the console here, and this code should be pretty simple code. It's recursively iterating, and it's taking an R value times X times 1 minus X. And then it just loops through the number of iterations and returns that array. So in Visual Studio Code on Windows, if you control backtick, that gets you to a terminal inside of Visual Studio Code. And I can do a .NET run right from here to spin up this controller endpoint. I'm going to let that spin up. And now we've got our path. I'm going to make sure I don't close Google Hangouts. And then I'm going to go to localhost 5001, API, bifurc. I'm going to do 2.0, skip equals 10, and iterations equal 100. And what we're going to see here is it settles down pretty quickly on a static value of 0.5. But this is a chaotic equation. And that means with certain numbers, the recursiveness almost looks random. So if I do 3.7, I'm getting a whole bunch of different numbers spit out. So what I want to do is use this to plot what that looks like on a chart. To facilitate that, I'm going to come over to my static Angular app. This is something you should be familiar with. There's no .NET magic going on here. I just did ngNew and created a static Angular app. I built a service, and I'm going to give the caveat that normally you might configure your base APIs somewhere else and inject them through dependency injection. I'm just keeping this demo simple to illustrate. I'm going to my localhost endpoint here, and I'm simply building up the parameters that I pass to the API and returning the result. So this is a pretty straightforward service. Normally I would break out this next piece into its own component, but again, keeping this simple, I just dropped a canvas, and this is an anchor tag in Angular so that I can reference this canvas from the code behind. We look at the code behind, and here's what I'm doing. I'm injecting that bifurcation service. I'm getting that handle to the canvas, and I'm getting the HTML canvas element. And this is what I love about TypeScript, right? I can cast it to the HTML canvas element and then get IntelliSense, so I know I can get a 2D context, set the width and the height. Then I'm basically making this 800 by 600 pixels, and I'm going for each pixel and turning it into an R value that's between 0 and 4, calling the service and plotting it. So that's what my Angular app's going to do. And again, I'm going to control backtick to the command line, and I'm going to do an ng serve and tell it to go ahead and open it for me. And this is where we see the magic of pulling in TypeScript, compiling it to JavaScript, parsing through Webpack. Webpack might shake a couple trees along the way, right? And give us an optimized bundle that, because we have source maps in our debug mode, we can debug through. There's nothing really magical that I need to show there. But we compile successfully. It pops me into my web browser, and you see the static app. But remember, I dropped a canvas in, so that's talking to the service and plotting these R values. And period 3 implies chaos. Here we've got it branching out. And if we were to zoom into these areas, they would be a repetition of the overall structure, which is what's really cool about fractals. That is how we use fractals to demonstrate Angular working with .NET Core. Let me close these out. Keep this one open so I don't see the Inception window. I don't want to step over myself as I run some other examples for you. But this is the first general way that these can run together. And of course, you can use any backend but .NET Core is well suited to be an API backend as well as authentication. Now, the next thing I'm going to show you doesn't require the Angular steps. I'm going to make a directory. I'm going to change to that directory. This time I'm going to say .NET New Angular. That's the Angular template. I have a link here so you can read about it and run it. What's different about this is what it generates is a combination of a .NET Core app with the Angular app embedded inside it. If we look here at controllers and a sample data controller, we can see this is a web API endpoint. There's a route to this. There's a get that comes out, and it returns some random weather information. So this is standing up an API endpoint. We've also got this client app, and inside the client app, it will look identical to what would happen if you did make dir client app and did ng new inside that client app directory. This is important because despite the integration points that I'm going to show you, this is a valid ng app. In fact, let me drop into my terminal. I'm going to change to that client app directory. And I'm going to do ng serve open. And the important thing I want to point out is even though I'm serving the app from this folder, with Angular's new capability of updating the project and having better upgrade experiences, combined with things like npm audit that are going to point out potential security vulnerabilities in your code base, you can manipulate it just like you would a standalone Angular app. And what will happen is that app will be updated and still integrated with the host. Now, because I just served the single page application portion, the client, I can go to the counter. This is client side code. I can increment this counter all day long. That's a lot of fun. But if I go to fetch data, I'm going to get this loading and it's never going to fetch the data. That's because I didn't start up the .NET Core side. I just served that Angular application. So I'm going to close this and stop this. I'm going to do something different. This time, let's do Control K, clear the window. This time I'm just going to do backup a directory. I'm going to do .NET Run. So I do .NET Run. And what's going to happen now is the integration is going to kick in. It will first stand up the .NET Core application. The .NET Core application, in turn, will talk to Node.js and have Node.js serve the Angular portion of this. This nuance is interesting because during debug, we have this interaction between the core host. When you publish this app, when you deploy it, it will actually bundle the Angular assets and serve it like a static web page, but you can still have things like source maps if you want for debugging purposes. So you can see it stood up the endpoint. Now it's stood up the Angular endpoint. So if I come back to my web browser, I'm just going to hit not the Angular 4200. I'm going to hit the .NET Core 5001. So we'll let that spin, loading. We get that same application. When I fetch data, boom, I get the data back. So now these are integrated. But let's do something a little more interesting, which I think is an even bigger advantage of combining these two applications. I'm going to Control-C here. I'm going to go into my sample data controller. Just close this out. And I'm just going to click inside this margin here and set a breakpoint at the start of this call. I'm also going to go inside my Angular source code. This is TypeScript, which we know gets compiled to JavaScript and bundled in a Webpack. And I'm going to put a breakpoint in the TypeScript code where we increment this counter. I'm going to go into my debug view, and I've set up a configuration which I'm going to post an article that explains the steps. There's also a document on the doc site that shows this. But we're doing ASP Core Net and browser. So when I press play for this debug experience from Visual Studio Code, this is going to stand up my application just like if I did .NET Run, but it is attaching a debugger to the server as well as the client. So I have seamless debugging between the two. We get a complaint at first because it started before the Angular portion was done. Now it's complaining because you can't keep a good .NET Core app happy. It wants a certificate store, and actually that's Chrome complaining to keep us safe, but I know this is my local development machine, so I'm going to continue. And there are instructions for installing the developer certificate so you don't get those warning for local development. But we'll let this spin up, and now it's loading the application. And we'll do the clockwise mouse rotation. So I'll go to the counter and I'll click increment, and boom, paused in Visual Studio Code. So let's look at Visual Studio Code, and we're in this breakpoint. I can hover over, see the current counter is 0. We can step over. Current counter is 1. We can play. So that worked brilliantly. Now let's go to fetch some data. So we do that, and I can see Visual Studio is flashing again. This time we're on our breakpoint. We're on the server side, so I can step over this. I can look at information within this window, manipulate it as necessary, click continue, and we get the weather forecast. That's the integrated debugging experience that you get when you combine the Angular and the .NET Core project. I'm going to go ahead and close this, and because it's integrated with the debug tool, it basically automatically stops the browser debugger, and then I manually stopped the server debugger, and I think we are good to go out of debug here.
I just want to tell you, Jeremy, you just made everybody so happy in the chat. Everybody's like, oh, that's cool.
Yeah, there have been many times I've wished I'd had something like that in my Java backend, but that never would have worked.
Right, and there's really 3 layers to that, right? The first was, if I'm using Webpack, and I'm going to actually show you in a second how to debug a Webpack from the browser in case people aren't familiar. How do I get from Webpack so I can step through my source TypeScript code, not the generated JavaScript or the mangled code that comes out in an optimized bundled site? And then the second piece is then adding the server. So very helpful capability. And if you're using Visual Studio, not Visual Studio Code, but Visual Studio, that integration also exists out of the box in that IDE. So having said that, that was our demo. This is Bit. This is a raccoon that represents all developer advocates. It's open source. It's not owned by our team. We have someone named Ashley McNamara, who is incredibly talented, amazing person, does these illustrations. And this is the .NET Core robot. So they're high-fiving because they're happy together. And I thought people would be happy to see that. So the benefits that we have, we retain the full use of the Angular CLI. We're not losing anything. We get source maps to debug through TypeScript. I didn't show this, but I still get that experience. If I change TypeScript code, the Webpack will recompile, and we can still have that live update as we're tweaking code. When we do a production build, .NET Core will instruct the Angular build to use ahead of time compilation to optimize that build, and you can tweak what those parameters are. The other piece that I'm going to step into now is pre-rendering or server-side rendering. Server-side rendering requires a few tweaks to the code base, and there's a document that explains what these are. I think this is overblown. People get overly excited about the concept of server-side rendering. A lot of applications can be designed in a way that you have a great experience. You get most of that template immediately, and then the data can backfill. But in some cases, it may just make sense to deliver some HTML quickly, have the server pre-render that, serve that out. And then what will happen is, if you've never done pre-rendering, it'll deliver that HTML so that there's a fast paint of the screen, if you will. And then it'll immediately run the client-side cycle so that if you have anything that doesn't make sense on the server to run, it can fill those in. I'm going to step in to hopefully shed some light on how that works and make it make more sense. This is, and by the way, all of these projects are on GitHub, so you'll be able to access them and work with them yourself. This is the same application that I just showed you. I've just made some tweaks for server-side rendering. The first thing I'm going to show you is actually in this startup, and there's a configuration provider. The way .NET Core, or ASP.NET Core, I should say, works is it assumes that you just want nothing but static web pages. and then you start adding in services and build up what you really need. So SPA static files are important because we know that we can have routes in the browser, and the server has to be smart enough to understand if you're doing like a client route or not, and then serve the other files statically. We've got exception handlers. We've got HTTPS redirection. This is all it takes to have that HTTPS support out of the box. And then we're going to use the SPA app and give it some options. And here I'm telling it to use pre-rendering and giving it some data, telling it where it can boot, where the module path is, how to use the builder. I'm also telling it to supply some data. So this one can be confusing to wrap your head around, but I'm calling, using string interpolation, I'm getting the OS of the server. I'm assigning it to this payload that I'm going to reference in TypeScript. What's important to note is the TypeScript payload is actually going to be referenced on the server. It's going to be running a node on the server so it can render that first pass of the application. If we go into the Angular app, you're going to see we have this main.ts, which is the original main. And here I've got a value that I'm putting into dependency injection called OS, and I just say this is on the client. Then I've got a server version of this that uses the parameter that I set in my .NET Core code. So this is passing it over to that Node app for pre-rendering. Then if we look at the app module, we can see we have our app module that's generated with ngNew. And then we've got an app server module that brings in this module map ngFactory loader and platform server. So it's bringing in some other services there. And then finally, I've changed this home component to inject that OS value that I'm setting and render it. So it says, hello, OS. Maybe not with that much enthusiasm, but let's go ahead and do a .NET run and let this spin up. We've got a lot of flywheels to start spinning in the background. The .NET Core actually comes up pretty quickly, but now we're waiting for the Node side to bundle the Webpack. So we'll let that go through and optimize and do all the fun things that Webpack does that makes it difficult for someone like me to build up a Webpack configuration file from scratch. I'm just going to put that out there. I like to liberally borrow existing configurations. We'll come back to our web page, and I'm going to use the same URL, but I'm going to use the home path. And what you're going to see if you look really closely, don't blink, we're still waiting for localhost. Dun, dun, dun. We get home, and we get nothing. There we go. I just didn't refresh at the right level. So it happened pretty quickly. What I'm going to do is jump into Chrome. And in sources, right now I've got a Webpack bundle going on. So if we look at this tree, we've got this Webpack that's exposed through Chrome. I'm going to expand this node. We've got node modules and source. I'm going to go into this main. And right here, I'm just going to set a little breakpoint. Then I'm going to zoom back out and hit this page again. So it'll refresh and we hit the breakpoint. What's happened is this is what's pre-rendered on the server. So we're serving that initial page up quickly, and you can see I've got the operating system showing right here. Immediately after rendering that, it calls the client-side rendering, and the client-side rendering then picks up that OS that I injected on the client-side code. So if we play through, then we get this is on the client. So that's a little visual representation of how that server-side rendering works. Now, it may seem cool the way the demo was set up, but in there be some dragons. Let's talk about those. If this will let me get back, yes. So one of the things to note is server-side rendering requires Node. You need Node to build Angular, but if you're bundling up your assets, you don't necessarily need Node to serve the output of an Angular application. That can be static. It can be a few other things. If you're using server-side rendering, you have to have Node in addition to .NET Core because it's Node that actually does the pre-rendering work. It will also publish the full Node modules directory. This will break the internet. Between this and Netflix streaming, that's all the bytes that we have left on the internet. You also need to be smart with your code. If you're sharing code between the server and the client, make sure you're not looking at things like window or local storage that don't exist on the server. And remember that client rendering triggers immediately. All right, I've talked a little bit about how they work together. I also want to show, based on what I've shared with these interactions, some quick and easy ways to host these, because I think that's an advantage too. Before I do, are there any deep, interesting questions to ponder or answer before I move on?
Sean had a question about syncing .NET view models and Angular types.
Okay.
He said, any suggestions on syncing .NET view models and Angular types? I've seen some kinds of TT scripts, but meh.
Yes. So I think what we're referring to is synchronizing so that our payloads look the same on the server as the client. So I have a C# object maybe that's a view model that has properties on it. And then I have a TypeScript interface that describes how I expect those properties to be on the client. And is there a simple way to synchronize those? And that is something that I have not come across. If you, I mean, the TT scripts is one way to do it. There's overhead involved with that. Most people I know basically do the work of the duplication of the properties. Now, there are some tools. There's a Visual Studio Code extension. I don't know off the top of my head, but it's right-click, copy as JSON. So you can build your view model, right-click, and then get a JSON representation of the data. There may be something similar for interfaces, but I don't know from the top of my head. Okay.
Well, he said that was the question. You got the question right. You got the answer right, or at least we know that we don't know. Yeah.
Right. So the really lazy way to do it would be client view model : any, but we don't want to go there, do we? That would avoid having to explicitly do the properties, but we would lose all our advantages of a strongly typed language. And friends don't recommend friends lose their typing or test time testing. All right, so I'm going to talk about 4 different flavors of hosting. Static website with Azure Storage, and I'll tell you why I think this is very compelling. Then Azure Functions, Azure App Service, Azure App Service for Linux. First thing I want to talk about is why do we have different models? And I'm going to go through this very briefly for people who aren't as familiar with cloud technology. I don't want to make any assumptions. This is my world in the past. I grew up with this of buying a physical server, pulling it out of the box, configuring software, sticking it in a data center, setting up redundant power supplies, and pretty much answering all of these questions and being responsible for the answer to every one of these. You know, I learned things I never thought I'd know as a developer when I directed my first IT department. Things like, did you know that there's redundant power that can get its own IP address so you can remotely power up and down plugs? That's pretty cool. I didn't know that, and I don't want to know that. That's why infrastructure as a service is much more manageable to me. This is the concept of basically the virtual machine. The idea is that we're abstracting the hardware away, and we're responsible for the operating system and everything on top of that. Our number of questions we have to answer go down dramatically. We still have to patch servers and deal with security and OS and dependencies, but we're not physically dealing with the hardware aspect. And this is what really enabled that jump from on-premise to the cloud. There's certainly people who have virtual machines on premises, but the same virtual machine images can run or be ported to the cloud. One thing Microsoft was early, in my opinion, in the game with, and was just ahead of its time before people got really excited about it, so they had to catch up a little bit on the infrastructure as a service side, is platform as a service. This says, why even worry about the operating system security and patches? I know I'm running an Apache version of this, or I know I'm running Internet Information Services for the .NET developers on there. They may cringe a little bit. It is a very powerful service, but configuring and troubleshooting was highly involved. Platform as a Service says we're going to serve up all the runtime and OS and all the backing things. You just worry about your project. So now you can ask the right size of servers, can I increase the utilization? How many do I scale out? And we have fewer dials to work with. This is what App Service is that I'm going to show you in Azure. This is a platform as a service. It will host web apps for us. And then finally, we have Serverless. It's a little bit of a buzzword, but it is maturing and it's getting a lot of acceptance and people are taking it seriously. It reduces the domain of questions. I'm going to show you the difference between a core API, which is basically a full app, versus a serverless app in a second. And this is what we call functions on the Azure platform. You may be familiar with, I believe Google Cloud calls them functions too. And I believe in AWS, these are Lambdas. Well, I know they're Lambdas in AWS. But this is the concept. So what is serverless? It's not no server. I tell people flip it around. It's less server. It means I have fewer concerns to deal with when it comes to the servers. They're abstracted away. It's typically event-driven and what we call instant scale. I write a piece of code and something triggers that code to run. I'm going to show you an HTTP trigger because Angular apps love talking to APIs. There are other types of triggers. You might have someone upload a file and that triggers a piece of code being run, or you may have a timer. There's all these different ways you can have your piece of code that's part of this typically microservices style architecture. I like to get in as many buzzwords as I can in a given talk, but the reality is that that is the way that you can scale that out. But here's something that I think is very important for serverless, and that's micro billing. That is paying just for what you use. And I'm going to show you what that looks like. This is a tweet of mine, and I'll bring it in closer so it's easier to read. I have my own link shortener. You probably saw the short links in the presentation. I do that for a number of reasons. When I'm sending links into Microsoft, I tend to track them so I can see a dashboard and figure out how effective am I. But really, what's important to me is that the content that I'm putting out there is content that people engage with and are excited about. So if I share a link and no one clicks on it, I know that's probably not interesting content. And I've learned different insights, such as any type of tweet that has the word architecture in it tends to get a lot more attention than one that doesn't. So if you want to tweet something about, here's a 101 guide to doing ABC, say, here's a 101 guide to doing ABC, we can talk about architecture later, and you'll probably still get more clicks on it. I don't know. That's what my stats show. But to do this, I run it completely serverless. I don't configure a website. I don't configure backend storage. I just have storage as a service. And in this snapshot, I actually get more calls. I get about 300,000 calls in a month now. This was back when there was 61,000. And something called 1435 gigabyte seconds. And gigabyte seconds are a way serverless platforms build. The way to understand them is I think it's very simple once you get this. Think of time on the x-axis. So going left to right, you're looking at time, 1 minute, 2 minutes, 3 minutes. And then on your y-axis, plot memory. So maybe it starts out 100 megabytes of memory, maybe it creeps up to 120, maybe it drops. So you're plotting memory over time. The area of that graph, the area under that line, is a gigabyte second. And that's what serverless builds on. So for this month's snapshot, it cost me 6 cents to run my functions. Cost me 36 cents to run my logic apps. Those are a different type of app that I use to tie in some analytics with Twitter. And my storage cost was 14 cents. So that's pretty affordable. In fact, that is so important to me about serverless that when I came up with my serverless rules that I'm still waiting to catch on, I think I need a better name for them. But the rules that I put out there basically is can it run entirely in the cloud? I think if you're doing a lot of work on premises to manage something that makes it easier for developers, it's still not serverless. It's not enough extraction. Some people will argue with that. Will it run in scale without me having to configure a virtual machine or a cluster? And the most important thing to me, do I only get billed for active invocations? In other words, if no one's hitting my endpoint, I don't want to be charged for it. And that's a key. And I don't know why my Alexa just woke up, but apparently there was something in there that she wanted to respond to. So let's talk about storage costs. This is my storage account. I'm using the current storage, which is V2. There's legacy V1 accounts that are being phased out. I have local redundancy. All of the storage is redundant. It's just whether or not you want geo redundancy or not. And I'll talk about geo redundancy in a second. I'm giving it a 1 gigabyte capacity. I'm assuming that I deploy my code. This is storage to hold my static files, by the way, for my Angular app. I'm assuming I might do 2 deployments every day for a month. Maybe I do more, but 600, you can see it comes out to a penny. So we could increase that. I'm assuming a ton of read operations. I'm assuming I get up to actually 1,000. So I guess 1,000 terabytes is what, a petabyte of data retrieval. And I don't know where this number comes from, but that's what defaulted to data write. Bottom line is, in this scenario, I'm getting charged about 42 cents a month for that storage. On my link shortener, I upgraded from local redundant storage to geo redundant storage. People actually started clicking a lot, and I decided it's probably pretty good if I have these links backed up and can get back to them if it goes away. So I upgraded to that. Now that I'm geo redundant, it costs me $1 a month for that storage. So I jumped from 10 cents to a dollar. If we look at functions, we get the first million invocations free. After that, you're billed per execution and per gigabyte second, and you get 400,000 gigabyte seconds for free too. So this is hypothetical, but it says, let's say I have a REST endpoint that takes an entire second to run, which is like ages, right, in the internet world. Too long. We wouldn't want one to take that long, but let's assume it took a whole second to run and chewed on 128 megabytes of memory that entire second. And let's assume we did 100,000 of these executions a day. So it's called 100,000 times. That's going to be, how do I do my math? Am I good on my math? 3 million per month. And that's going to cost us 40 cents. This is a pricing calculator. So very economical combination. And then app service is a little more expensive. I basically have a dedicated service. So even when it's not being used, I'm still billing so that I have it always on. I have some levers. I can change the size of that service, and I can also change the number of instances to scale it out. But assuming one instance for 730 hours, this is going to come out to about $44 a month to host that platform as a service. So it gives you a little bit to compare. Let's see what this looks like in practical terms. I actually have a few things open. So this is my Azure portal where I deal with all my resources in Azure. And I've taken the liberty of creating some resources ahead of time so that you don't have to wait to see it happen. But I want to show you how we host our static Angular files. I'm going to drill into this, which is my storage. It's my storage account, and those costs that I showed apply to that. And what I did is I came over to this static website. Now this is in preview, so there's some caveats for it, but for the most part, this is going to mature and be released and be everything we want it to be. I ask it to have a static website, I enable it, and it comes up with this special container for me called $web. And it also gives me this endpoint, which it's funny, it's blurred out because I have security turned on, but when I hover over, you can see the endpoint. But even it's not that I don't want you to see it, and I can always just copy it here. So I'm going to copy that. That's on my clipboard. What that does is in my blob storage, which is storage just for random unstructured data that you want to upload, you can store videos, files, anything like that. We go into this and we see Angular assets. This is the output of an Angular build. Everything bundled up. I do upload. It lets me open this folder. I browse to my files, I upload them, and we're done. What that looks like on the other side, we'll go ahead and paste this endpoint in, is my static app. And I have this hooked up to a function. And hopefully that function is up and running and doing fine. Come on, function, wake up. There it goes. And we can see the bifurcation diagram coming in and drawing. So this is using a static website to serve the Angular assets, and then it's talking to a Angular function on the other side. Let me just pop over and talk about the Angular function. The way you do a function, you can generate these functions and work with them in Visual Studio Code. If you're in Visual Studio itself, I just wanted to show you the experience for creating a new project. I showed you the command line. We did .NET New, and we had all these options. We can go into .NET Core here, and we get these options to pick our different type of .NET Core apps. If we pick a web app and we click OK, then what this is going to do is prompt me for the type of template that I want. So I can do what's called Blazor, which is a cool thing that's outside the scope of what we're going to talk about. I can do the Angular template, React with Redux, a few other things. That's the IDE experience of doing this. I'm going to go back into my function. To create one of these serverless function apps, you just do file new function, and you get a class. And on that class, you have different methods. Here I have a method for a function name called bifurc. And then you use triggers to indicate how these are run. Remember, I said triggers could be timers. It could be a database trigger. It could be anything. In this case, I'm using an HTTP trigger. I'm telling it it's a GET. Here's the route. It's going to automatically set up a listener for me, automatically stand up that endpoint, and just pass these values in. And then these values come in, and I'm doing the same thing that the core API app did. This is actually .NET Core code that's running in the functions host. But what I get from this is something pretty incredible. And let me see if this is working to show you, because a live demonstration goes a long way. Let's go back to here and jump back into our function app. And I want everyone to cross their fingers, because I may have set this up incorrectly. And we've got, this is what happens when you set something up incorrectly. This is the cloud crying, a big, big tear.
You just had to show it to us wrong so that you could show us then right.
Right.
Plus, you just showed us something that Ben was trying to do for a while, so don't worry. We still love you. But why didn't it work?
It was a setting that I had to map the application insights into the function app. I had created it a couple times. There's a dialog that does it automatically, but I did something wrong and tried to recover manually, and I did not do it successfully. But what we can do is, I'm actually going to go off script for a second. Let me stop sharing. I'm still sharing, but let me stop sharing. And I'm going to open up, because I want you to see this benefit of functions, and then we'll talk about app service and then have a little time saved for questions. So I'm going into a pre-recorded demo that I did for times like this. And let's go dun dun dun. Let's go dun dun dun. That's very helpful, right? When I say dun dun dun, you know
that
what
is
I'm
helpful. We like.
doing.
I was thinking I really need to get some sound effects for this show. There was a couple times in your talk that we needed some sound effects, and the people in the chat were getting all excited a couple times.
Well, I brought my kitty, so I have that.
Yeah, and Lance's cat. Lance's cat joins us sometimes. That's how we know we're doing well.
That is awesome. I'm coming back to Google Hangouts, and I'm going back to screen share. Come on, screen share. You were just there. Oh, there we go. Screen share. Yes, share the entire screen. Okay, now I'm screen sharing, having that Inception moment. So I'm going to jump ahead. You don't need to see how I create the function. I deploy it. I do da-da-da. This is deploying an endpoint. This endpoint's actually a lot simpler than what I just showed you. This just echoes a name back. You pass in a name and it echoes it back. But what I'm doing is something that everyone here may be a little familiar with. Has anyone used artillery? I guess anyone who can speak. Anyone on our panel? Have you heard of artillery?
I don't know it at all.
There are a bunch of people in the chat who seem to know exactly what you're talking about. We have a lot of
So our artillery helps with load testing. And what I'm showing you here is the built-in telemetry we get for function apps. You just check a box and you get telemetry that you can debug. You have this live stream. What this stream is showing me is it's showing me the servers that are servicing the requests. It's showing me outgoing requests, health, etc., incoming requests. I'm just closing off some ones that aren't as interesting. And then I'm going to hit that endpoint that just echoes the name back. Boom. And it's going to echo it back. And if I look at that live telemetry, what you'll see is that we have a little blip. So it basically showed the request, took about 8 milliseconds to serve the request. We have one server, everything's fine. Here's the magic of serverless. This is just me looking behind the curtain, seeing the wizard in the back. I'm not doing anything myself, but I'm running artillery and telling it to emulate 100 users doing 100 hits on this function endpoint. So I'm running artillery, it's going out, it's sending all these requests. Now what you're going to see is you're going to see the requests jump up. That's that spike. Azure is immediately going to recognize that we need more servers, and it's just provisioned 3 more servers. There was a delay. Someone had to settle for a 30 millisecond response time, and then it dropped back down and is load balanced evenly, and we're back to pretty much 8 milliseconds across the board. So that's going through. You can see I jumped ahead a little bit so you don't have to wait. The requests are done. All of the requests came in quickly. It provisioned just the right number of servers automatically behind the scenes, and all 10,000 hits were a success code. So that's another advantage of going with this route, is this capability to auto scale. If you decide to take on a .NET Core app and you are looking to host a function, the experience, there's an extension in Visual Studio Code that does some of the similar things just through text-based dialogues. In Visual Studio itself, I just right-click, do publish, and I get a dialog that walks me through setting up the resource, bundles up my code, and sends it out. If we look on the side, this is connected to Azure, and it's letting me look at things like if I look at the function app, I can do things like open it to look at it in the portal. I can attach a debugger, so I can debug locally against my deployed example. I can even go to files, and in files, I can download them as a zip to browse them or explore them here. So there's a lot of capabilities there. I did talk about another way, though. This is a function app where we're basically dealing with endpoints. I do have a hosted app, and here's something interesting to note. This is the same app I showed you in Visual Studio Code. The only difference is I'm just opening it in Visual Studio. So I just wanted to show for some people who use Visual Studio, I can work on the exact same application. I could press play to debug and step through all the same ways. When I'm using an app, not a serverless app, but a full-blown website, so this is Angular and .NET Core bundled together, I do this right-click publish, and then I get stepped through exactly what I need to set up the web app. And I'm going to just do a new profile. And you can see here, I have these options. I can do app service, which is on Windows, app service on Linux. I could pre-configure a virtual machine and deploy to that and go through that. So if I do create new, for example, here, let's do Linux, create new. Let me zoom back out. And if I hit publish here, it's going to prompt me to create all the resources that I need to host this. I basically give it a unique name, give it a subscription, which tells them where to send the bill, give it a resource group, which is going to group all the related assets together, and then give a hosting plan, which tells it, is this consumption-based, what you saw with the auto scale, or am I going to just set up a fixed number of servers? It's basically how I want to scale my application. Once that profile is created, I can just make updates and publish to that profile, or I can come down here and can configure continuous delivery, which will work with our DevOps solution to set up a continuous integration pipeline, which I do not have time for to show here, but I want to point out that that's an option to explore further. The last thing I want to show is just the result of that right-click publish is this hosted web app. And we've got a few dials that we can run with. I'm looking at it in the portal. And if we look at the side, we can see that I have options to scale up. So on the fly, I can tell it to do more codes, do more memory, anything that I need. I can also scale out and tell it to run more instances. I do that on the fly. Here I can get my URL, copy that. And what I did is I literally just took that ngHouston app that I generated from the template and deployed it directly to Azure. And this came up to the website that I showed you earlier. But you can see that it's running the Angular fine. It's packaged and provisioned those files, but it also has this interactivity between the client side and the server using that web app experience. Having said that, I want to wrap up with a link wall. Everything I showed you is on this GitHub account. I'm going to tweet the link to this deck. So if you don't want to take a screenshot and don't want to write down a ton of links, don't worry about it. You can download the full deck. My decks are open source. If someone wants to take it and turn around and present Angular.net to someone else, you are 100% free to do it, and you can reach out to me and we'll collaborate. Having said that, everything you need to get a hold of me is here. I would like to pause. We've got about 20 minutes left. So if you have questions, I'm going to hang out and answer them to the best of my abilities.
Do we have questions?
Yeah, I don't. Go ahead. Go ahead.
I was going to say we've been going along and jumping in with questions. Mostly we have had a lot of happiness. These people in the chat really like you. You have to come back here again, Jeremy, because you're pretty cool. What were you going to say, Lance?
I was just going to say I didn't have any questions. I mean, someone did ask for confirmation. You said the CLI is available using Visual Studio. Is that correct?
That is correct. You're not going to run the CLI from within Visual Studio. What's going to happen is if you launch the debugger from Visual Studio, it'll automatically call into the CLI to serve the application so that you can debug between the client and the server. If you want to do commands like ngUpdate or npm audit or whatever, you can just open a console window and run those commands. So there's not like right click ng new inside Visual Studio, but it still works off the same premise and the same engine. It's using Node.js and communicating with it to do the builds, to set up the debug, all the other components of that experience.
I don't think we have more questions. I mean, the only question I have is when can you come back again? Because this has been a pretty popular topic and a popular episode. And we had some goofy people in the chat tonight. They're pretty funny.
Yeah, I'll have to go back and read the transcript. Obviously, I haven't mastered the art of training one eye on the chat window and the other eye on the presentation. That would be useful to have. It'd probably freak people out, but so I missed out on some of the chat items, but I'll go back and look through that. And again, anyone is free to reach out to me any way they like. And I would love to come back. It means I get to play with Angular more. I feel like I took a little bit of a break from Angular. That's all I worked on for several years in consulting. When I transitioned to this role, I did a lot of fire hose picking up and understanding Azure and all those elements. But I've always loved Angular, and it's my go-to framework for tinkering with applications or building solutions. And we get pulled in sometimes to customer engagements where we get to see full live production, scaled out implementations that are using it. And that's where I get a lot of insights and caveats and feedback for that. So to answer your question, would love to come back. I just want to make sure I have more interesting information to share on top of what we presented today.
And you're pretty funny.
That is good to know. I try to be. My daughter tells me I fail. So,
well, you tell her we said. So we do have a couple more questions. Ben wants to know, what would you generally use for authentication if you're using a function as a service backend with an Angular app?
Function as a service backend with an Angular app. So, I mean, there's several routes you can go. It's interesting because I would normally say I would use JWT. There's a great provider in .NET Core to create a JSON web token. And then obviously you can use an interceptor in Angular for that. I've noticed that lately people are saying, oh, stop doing authentication with JavaScript web tokens. I'm not quite sure why. I haven't dug into that. But you can use any type of identity provider. And you can also, this is interesting because traditionally as developers, I think we've looked at authentication as a development concern and authorization, and we've done a lot of code to make it happen. When you host in the cloud, and of course I know Azure, so I'm going to speak to that, but this is capabilities in all the clouds, you can start to shift towards a hosted authentication mechanism. We did a developer tour, and I got to travel to Singapore for one of those sessions and deliver it. But what we showed was taking a app and through configuration with how it was hosted, wrapping it with authorization. And what happened was the host, in this case Azure, managed the identity portion of that. So it would hand off to Google or Microsoft account or Twitter or Facebook, whatever you configured as your provider for identity. And then it would have a URL accessible within the application with the token that you could then pull down and use for things to decrypt it and look at, am I authorized to this component or not? So the only development piece you had to do is the piece where you pulled off the information. Like you knew someone wasn't in the app unless they were authenticated. And then if you needed to restrict access based on authorization, you could go to a URL and get that. That's provided by the host. So that is something I think is intriguing as well, to take that concern out of the app. And then that way, if their protocol changes, if the way Twitter hands out API keys changes, I don't have to change my code. That's going to be Azure's responsibility to take care of that. And they're still going to pass me the information I need to keep my app working. So those are my two answers. Look into identity providers or look into .NET Core has one that out of the box can do the handshakes and will prevent access to certain paths of the website based on how you set that up. And then, of course, a JavaScript web token you can parse out on the Angular side.
I love it. I think that's it for tonight, huh? Will you turn off your screen so we can see you?
I can do that. I'm going to stop sharing. It sounds so sad, though, right? Because we want to share all the time. But
yeah, but we have to see your face, too, so we can tell you how much we love you and how awesome you are. This actually has been, I think, probably my most popular episode of all time, at least while it's live. Normally, we just have like, 3 or 4 people watching live, and then everybody goes and watches the YouTube video later. But this has been hopping, and we had a lot of fun in the chat too. We had some silly people in the chat.
That's awesome. Well, thanks everyone for making this popular. Deeply appreciate it.
Yeah, absolutely. And I think they definitely do. So there's a couple people that, like, I actually never really dove into .NET. And I was always a little bit intimidated because I always thought the .NET guys were like, the cool kids. But this, I mean, you just make it really seem so approachable. Like it's not so, it's still cool. It's just not as scary, because you just have a knack for just making things seem simple, which is the mark of a good teacher. So that's great.
I'll take some credit for that, but I do want to point out that we've got a new wave of tutorials on the sites. I said we're really heavy on content, right? So if you go into the quick start that I linked to, we've got a version of the .NET engine that runs in browser. So there are tutorials that you don't even have to go through the headache of installing. You could try before you buy, if you will, and walk through and write code and execute it right in the browser. So the goal is just to make that experience as easy as possible. And I think it's a great low-hanging fruit for people who want to kick the tires and look at what this is all about.
We do love kicking tires. That's great. You're great. Thank you so much, Jeremy, for coming on the show and for being fun and teaching us cool stuff. And I do hope you'll come back again soon.
Absolutely, my pleasure. I will post the links to the meetup. I will also tweet the links out, and I have an article series based on this talk. It'll be a 4-part series that I'll tweet out the links for that as well. Thank you, everyone. Appreciate it. It's been a great time.
Thank you. We'll see y'all next week.
Bye.